Hi again, everybody, and welcome back. In this video, I'm going to walk through the problems in homework 10.3, starting with problem number 5. Up to this point, I think that all the previous problems were either conceptual or didn't have any real values, but 5 is one of the first one that has values, and I'm going to walk through how to solve these problems using the idea or the concept of conservation of momentum. All right, now what conservation of momentum means is that momentum before and after any kind of collision is assumed to be the same. All right, so the net momentum initial equals the net momentum final. All right, that's going to make all the difference in these types of problems. So in this first problem right here, we have a bullet and a rifle. All right, so the mass. In fact, I'm probably gonna run out of space. So I'm going to zoom in here a little bit. Like that, I think. All right. So the mass of the bullet. Oops, I'm moving the page around. The mass of the bullet is going to be 13 grams, which of course is 0.013 kilograms. Okay. The mass of the rifle, MR, that is 4.5. Come on now, 4.5 kilograms, and we don't need to change anything there because it's already in the units that we care about. Okay, and what this means here, the muzzle velocity, that means when we're speaking firearm language, which I don't know a whole lot about firearms, but I do know that muzzle velocity refers to the velocity of the bullet as it exits the rifle. So it really refers to the bullet. So the final velocity of the bullet is that 900 meters per second, okay? Meters per second. And what we want to find is the recoil speed. Well, what does that mean? Well, that means the speed with which the rifle kicks backwards. Any kind of gun will have some sort of a kick, as they call it. And so we want to find that. So we're really finding the final velocity of the rifle. That's what we want to know right there. All right, now let's just draw this real quickly here. All right, so over on the let's see, the right-hand side, I'm going to do something that looks a little bit like, I don't know, just an L-shaped thing. Okay, there's a gun. The reason I drew it, it looks like a fork, sort of, or like an F. The reason I drew it like that is because it's supposed to be like a cross-section of the barrel of the gun, all right? And before the bullet is shot, it is inside the barrel right there. Okay, now what is the momentum of the system right there? The net momentum of that whole system initially. Well, it's equal to 0, right? Because the gun is not moving, nor is the bullet moving. But if somebody pulls the trigger, all right, and again, this is a kind of a dumb-looking gun right here, but this is supposed to be a kind of a cross-section of a gun. It's not really even a rifle, but it looks like a pistol almost. But this is supposed to be the cross-section where you can see inside the barrel. What's happening is this gun is kicking backwards as the bullet is firing forwards, like that. Okay, and that's because there has been inside that barrel, there has been like an explosion. That's the bullet, the gunpowder going off and propelling the bullet out, but also propelling the gun backwards. So the point here is that the net momentum after the bullet has been fired is equal to the initial momentum. And so the final momentum is going to be equal to 0 as well. Okay, so that's our assumption right here. The net momentum initial, which is 0, equals the net momentum final. Well, we said the whole system has 0 momentum initially because it's not moving, all right? But the parts in the system are moving after the bullet has been fired right there. So what we need to do is find the final momentum of the bullet and the final momentum of the rifle. That's what we call the recoil speed. Now, the rifle is moving this way, kicking backwards, and the bullet, of course, is moving this way right here. So they're going to have different directions. If a velocity has a different direction, that means it's going to be positive or negative. So we're getting a little bit ahead of ourselves here. So let's write an equation for this this final momentum of the system. All right. Well, first of all, we know the first part is going to be 0 right there. All right. Well, the final momentum of the system is going to be the momentum of the bullet, that's a B right there, plus the momentum of the rifle. All right? And so if we want to find the final velocity of the rifle, or the recoil speed, let's kind of get these away from each other right here. So I'm going to subtract the final momentum of the bullet over to that side. So the negative final momentum of the bullet. Oh, you know what? I forgot my F in there. This is final velocities here. Equals the final momentum of the rifle. Okay. Now, how can we expand these out right here to kind of get this final velocity of the rifle? Well, we know how to do that. By the way, this is all part A. I'll write a part A on. Oh, there we go. On that side right there. Like I said, this is all part A. But we have an equation for the momentum at any one point. That's mass times velocity. Negative. Let's draw this over here. Negative mass of the bullet times the velocity final of the bullet, which we know, equals the mass of the rifle times the final velocity of the rifle right there. We know the mass of the rifle. That's what we're solving for, the final velocity of the rifle. All we need to do is divide down by the mass of the rifle, and we have an equation for the final velocity of a rifle. I'm going to write it here up top. So the final velocity of the rifle is going to be negative mass of the bullet times final velocity of the bullet divided by mass of the rifle. All right, all those values we have, all we need to do is just plug in. All right, and by the way, if we're calling the final velocity of the bullet right here, that's this direction. If we're calling that 900 meters per second, what should we do with its opposite direction? Well, we should expect it to be negative, right? And I think we are going to get a negative velocity for the final velocity of the gun, all right, of the rifle. Okay, so it's going to be what? What's the mass of our bullet? Right, well, the mass of the bullet is 0.013 kilograms, right? So negative 0.013 kilograms times the final velocity of the bullet, that's 900 meters per second. All that divided by the mass of, that should be an R right there, the mass of the rifle, which is 4.5 kilograms. And that's going to give us a final velocity of, not the bullet, of the, because we know the bullet, of the rifle. All right, and it's going to be negative something because the rifle is kicking in the opposite direction, the negative direction that the bullet is going in right there. So 0.013 times 900 divided by 4.5, 2.6. Negative 2.6 meters per second, or 2.6 meters per second in the negative direction. So that's the final velocity of the rifle. The reason it's so much less than the final velocity of the bullet is because the rifle has greater mass. The lesser mass bullet is going to be traveling at a much greater speed because they both experience the same change in momentum. Okay? All right, let's go ahead and do part B and C, and this should be pretty easy right here. Part B is, I'll do that over here on the over on the right. The kinetic energy of the bullet. So KB right there. Well, kinetic energy, we know, is 1/2 mv squared. So it's going to be 1/2 mass of the bullet times final velocity of the bullet squared. All right, so it's going to be 0.5. I like to write it in like that, especially for when we calculate it. Times the mass of the bullet, that's 0.013 kilograms, times the final velocity of the bullet, that is 900 meters per second. That value squared right there. That's going to be the kinetic energy of the bullet. I should put KF for final. Kinetic energy of the bullet final, because the initial kinetic energy of the bullet is 0, right? In fact, the whole system has 0 kinetic energy, but it has a lot of kinetic energy after the bullet has been fired, after that explosion has taken place. So what is that value? 0.5 times 0.013 times 900 squared. 900 squared. 5,265 joules. That is our final kinetic energy of the bullet. And there's our answer, right there, 5265. Same thing is true for part C. Final kinetic energy of the rifle. That's going to be 1/2 mass of the rifle times final velocity of the rifle squared. Okay, so it's going to be 0.5 times mass of the rifle. That's 4.5, right? Times final velocity of the rifle. That's 2. I was going to write a -2, but negative anything squared is just positive. 2.6 squared. That's going to give us final kinetic energy of the rifle. 0.5 times 4.5 times 2.6, that value squared, 15.2. 15.2 joules, and our answer key up here confirms that. All right, so point here is that momentum is conserved. The system has the same initial momentum, 0, or the same final momentum, 0, as it does initially. That's because these velocities cancel out and add up to 0. Right, the positive momentum and then the negative momentum. But what is not conserved is energy. No energy to begin with, but a lot of energy this way and a good deal of energy that way as well, because energy is not direction dependent. So you can't have positives and negatives cancel each other out. All right, so momentum is conserved, but energy is not. All right, that's going to be it for this problem right here. Thanks for following along. I'll see you on the next one.